Assalamualaikum and hi. In this video, I will explain question 1 on joint and imaginary probabilities distributions and expected values. So we are given 7 components consisting of 4 microchips, 2 resistors and 1 capacitor. 3 components are randomly selected without replacement. So in this experiment, X represents the number of microchips selected and Y represents the number of resistors selected. To find the joint probability distribution of X and Y, we use combinations. The total number of possible outcomes is 7C3. The joint probability of Px equals X and Y equals Y is calculated using 4Cx multiplied by 2Cy multiplied by 1C3 minus X minus Y divided by 7C3. All valid probabilities are then arranged into a joint distribution table. The marginal distribution of X, denoted as Gx, is obtained by summing each row, while the marginal distribution of Y, denoted as Hy, is obtained by summing each column. To check whether X and Y are independent, we compare a joint probability with the product of the marginal probabilities. For example, Px equals 2 and Y equals 0 is equal to 6/35, while Px equals 2 multiplied by Py equals 0 is equal to 36/245. Since these values are not equal, X and Y are not independent. And next, we'll calculate the expected values. The expected values of X, written as Ex, is equal to the summation of X multiplied by Gx, which give Ex equals to 12/7. Similarly, the expected value of Y, written as Ey, is equal to the summation of Y multiplied by Hy, which give Ey equals 6/7. And next, I will explain the solution to a question involving the joint probability distribution of two discrete linear variables, X and Y. So the question is divided into two parts. The first part focuses on finding the marginal distributions and the conditional probability. For the second part, involve calculating the covariance between X and Y. So I will begin by finding the marginal distribution of Y by summing the joint probabilities across all values of X. When Y is equal to 1, the probability is 0.39. When Y is equal to 2, the probability is 0.35. When Y is equal to 3, the probability is 0.26. Next, I will find the marginal distribution of X. When X is equal to 1, the probability is 0.43. When X is equal to 2, the probability is 0.57. Both marginal distributions are valid since the total probability equals to 1. And next, I will calculate the conditional probability that X is greater than or equal to 2, given that Y is equal to 2. Since X can only take the values 1 and 2, this condition means that X is equal to 2. The conditional probability is calculated by dividing the joint probability of X equals 2 and Y equals 2 by the probability that Y equals 2. This gives a final answer of 0.6286. And next, I will calculate the expected values of X and Y. The expected value of X is obtained by multiplying each value of X by its marginal probability, giving an expected value of 1.57. For expected value of Y is calculated in the same way and gives an expected value of 1.87. And lastly, I will calculate the covariance between X and Y. First, I will find the expected values of the product of X and Y, which is equal to 2.88. The covariance is then calculated by subtracting the product of the expected values of X and Y from the expected value of the product of X and Y. This results in a covariance of negative 0.0559, indicating a weak negative relationship between X and Y.
And now we move on to question 2.
Question A1.
A joint density function are given of two random variables x and y. So to find the marginal densities of x and y, we have to integrate density function with respect to the other variable. So to find marginal density of x, we integrate fxy with respect to y. So after integrating, we substitute the limit 0 to 4, and then we simplify the expression, and we get 1 over 15 2x plus 2x 0 to 3. And next, marginal density of y. We integrate fxy with respect to x, and after integrating, we substitute the limit 0 to 3, and we simplify the expression, and we get 1 over 23 plus y 0 to 4. On this slide, I'm explaining the region where x plus y is less than equal to 2. The line x plus y equal to 2 forms a triangle in the first quadrant with the intercept at 2, 0, and 0, 2. For every value of s between 0 and 2, the value of y goes from 0 up to 2 minus x. So the shaded area shows all the points that satisfy the condition x plus y is less than equal to 2. So this is why the limits of integration are x from 0 to 2, and for each x, y from 0 to 2 minus x. Now I'm showing the full calculation for the probability. So we start with double integral. We put 1 over 60 to the front, and we integrate 2x plus y with respect to y. And we substitute the limit 0 to 2 minus x. We simplify the expression, and then after got the answer, we integrate with respect to x as well. We substitute the limit 0 to 2, and we simplify, and the final answer we got 1 over 50. Moving on to the next question, B1. So they asked to find expected value of x, expected value of y, and expected value of xy. To find expected value of x, we have to double integrate 0 to 1, 0 to x, and the density function multiply with x. So we integrate with respect to y, and we substitute the limit 0 to x. After that, we integrate with respect to x, and substitute the limit 0 to 1, and the final answer we got 4 over 5. And next, to find expected value of y, we double integrate 0 to 1, 0 to x, and we multiply the density function with y, and we integrate with respect to y, substitute the limit 0 to x, and after that, we integrate with respect to x, substitute the limit 0 to 1, and the final answer we got 8 over 15. Continue to find expected value of sy. Double integrate 0 to 1, 0 to x, and the density function multiply with xy. So we integrate with respect to y, and we substitute the limit 0 to x. After that, we integrate again with respect to x, substitute the limit 0 to 1, and we simplify the function, and the final answer we got 4 over 9. Moving to the last question. Calculate the covariance of x and y. Are x and y independent? So to find covariance x and y, the formula is expected value xy minus expected value of x times expected value of y. So we substitute the value from the answer that we got from B1. So we substitute 4 over 9 minus 4 over 5 multiply 8 over 15, and final answer got 4 over 225. Since the answer is not equal to 0, so that x and y are not independent. That's all from us. Thank you.